Alright, so here I have x2 plus 2x plus 1 divided by x to the 3. So here's a very good example that if you split up the polynomial up here into monomials, it actually really works out, and you'll see why in the end. So I'm going to split up my polynomials into binomials. So I have 2x divided by x3, add 2x divided by x3, add 1 divided by x3. Okay, so now I have monomials. Okay, now I'm gonna go one by one here. So I have x to the 2, x to the 3, so I'm going to subtract by 2 because that's the smaller exponent. I'm going to have nothing on the top because the 2 minus 2 is 0, so I'm just going to cross it out. I'll have a 1 there because I need to hold that place value, because down here 3 minus 2, well, that's just going to be x to the 1, or just x. Now let's go to the next one. Numerical coefficient to work with, so I have 2 divided by, technically there's a 1, 2 divided by 1, that's just still a 2. Okay. Now I have x to the 1 divided by x to the 3, so I'm going to subtract by 1 because 1 is smaller than 3. That cancels out the x in the top, so I have no more x's in the top. But in the bottom, I'm going to have x3 minus 1, I'm going to have x to the 2. Okay, now let's look at the last one. Is there anything to do here? Nope, there's just the 1 x to the 3, that's happy. Okay, so we're just going to leave 1 x to the 3. So as you can see here, when I split up that polynomial into monomials, I'm easily able to derive the answer versus me just dividing straight through. So that's the answer.